What teacher gave those to you? Spanish. How do you say egg in Spanish? Huevos. Very nice. Did you know that before you took Spanish?
It's like common knowledge.
Some people don't.
Did I show you my updated one?
Yes, very nice. Except brain matter is not red, it's gray. That's why it's literally called gray matter.
But the blood
There's actually
vessels
two
in it-
types, gray and white.
Yes, I'm aware.
I'll show you a picture of brain. It's not going to be red, it's going to be gray.
I know, but a fresh brain is usually going to be red because the blood vessels still in it are still pumping. And if there's a
No,
head
it's going to be
trauma-
gray.
No. Head trauma also causes blood.
That's not brain, that's your vessels, though. But the
Yes.
brain itself is gray
I'm not.
until you get to the white part.
You get the white part. Okay.
You're going to make me show you a picture of a brain.
Yeah, go ahead. Look up fresh brain. It's going to be pinkish red.
Well, if you go to the grocery store, it's red.
Well, it's a fresh brain, isn't it? The person's barely even dead.
Actually, a lot of times in the grocery store, it's gray too.
I mean, yeah, but usually they try to pump it up.
You just have never looked.
Yeah, you can find brains. You can also find tongues.
Brains, tongues, kidneys, heart, feet. What are some other weird things? Liver. You go to Safeway, they got brains there. You go to Walmart, they got brains there too. If you ever go to a restaurant, they say sweet bread, it ain't sweet bread.
Oh yeah, I know that.
Sweet bread is what they call brains. Because I don't know, maybe the idea of eating brains is kind of weird. I actually will not eat any brains. I just think that I'm going to stick to muscles, and that's it.
Brains. I would recommend making more smarter and during our discussion, I forgot to go get my notebook, so I need to go do that now.
It wasn't much of a discussion. Okay, questions on the homework? Questions on the homework. I'll get with you at the end of class, Taylor.
I won't do it.
Actually, no, I'll hand you
11
the
and 12.
11 and 12. Let's take a look at
Why
11 and
was it
12.
not like what we did in class?
It was like we did in class.
No, it wasn't. It was a chart. We didn't do a chart in class. Chart.
This book loves its charts. All right.
No.
11 and 12. I'll do 11 for you. So it says the area of sector AOB, the area of sector AOB is 10 pi. So we got a circle, and we got AOB, and we're told that the area is equal to 10 pi? Yeah, 10 pi. 10 pi. And I wrote pi. 10 pi. And the measure of AOB is 100 degrees. So we know this is 100 degrees. Okay. Find the radius. So we got one formula that had radius, and what was it? So area of the sector, right, is equal to x over 360, where x is the angle. So I can automatically put 100 over 360 times pi r squared. Okay, so pi r squared, and we're told this whole thing equals what? 10 pi. Okay, so what's the easiest thing to do first?
Take off the zeros.
Okay, this was what we call this match rule.
It's like 30.
I'm gonna call that math rule for the rest of
All right, now what's the easiest thing to do?
With the pies.
I'm going to say cancel into pi, so we're going to divide both sides by pi. Look.
Oh my gosh.
Look. I have no idea. Look, the pen explodes. All right.
I mean, that's a food transition. I'll probably give you that.
All right. Next. You're not going to like this. One's pretty simple.
I don't. Can you reduce 10?
You can. 2 goes into both.
Oh, so.
So we get 10 is equal to, that would reduce to 5 over 18. And we still have that r squared over there. Yuck.
Can you square root it to your.
Eventually, that's going to be our last step. But before we do that, copy dot flip, right? So we're going to do a copy dot flip. So that would be 18 over 5. Look, some things cancel. That's oh, you're not going to like this. 2 times 18 equals Oh, you're not gonna like that. Therefore, R is 6. It's actually pretty easy.
Okay, I
Don't. So much of this is it's the same thing we had the conversation we did the algebra review. It's like yeah, it's higher level math. It's gonna look messy at the start. A math teacher wrote this question. It's only question number 11 or 12. It's probably until you get to the 20s and the 30s, it's probably a pretty simple thing, but you got to be willing to jump in there and do it. That's a classic example there. Oh, look, it's just 6. All right, it's Friday, so I'm just going to collect the homework. But if you do have any specific questions,
On Fridays, we don't get homework, right?
no. Fridays, I just don't have time to like call out all the answers. All right. Pass the basket around, toss that in there, and we're going to do something today that is, I'm going to say in general terms, I know you might not agree with me, but in general terms, yesterday was an easier day. Today is
Or day, of course.
it's medium. Some of you are going to somewhat struggle with this. Others of you are going to get it immediately. It's not that bad. But I will say that I would agree that today's more medium as compared to yesterday. You're going to get 4 things.
Did you ever take my homework?
4 things.
Give me your homework. And then you're gonna take it home with me. Okay, that's fine. Hey, my homework, boy.
Oh my word. You guys are never going to get dates.
Dang. Oh, that cut deep. That cut deep.
Why do you tell us what we already know?
We're making our reality anything.
All right.
Don't like that. That was kind of dirty.
By the end of the year, I guarantee you, this.
You all get married. It's just that some of you will take longer than others.
All right, just gonna try to set you up with your daughter.
You know, I'm just gonna give up.
Personal note. So my wife said I have to go see my oldest daughter, who's 24. She said we're going to go meet the boyfriend.
Oh, are you gonna have the dad talk with him?
Well,
Bring a guy
I told her, and I told my wife ever since we had girls. I said, hey, I don't need, nor do I want to know boyfriends until it gets serious. And so she goes, we got to go meet the boyfriend. I was like, really? So supposedly, I don't know. We'll find out. Okay.
Bring your gun.
Can you like tell if it's gonna work out or not?
I don't know. I'm a guy, so I don't know. I'm not wise to I didn't know I was going to get married until my wife told me we were getting married. Right? You will know when the right time comes. Here's your homework.
Yay!
Yeah,
I love it when you give us our homework before class begins.
I always do that.
Not all the time.
Really, we have
Sometimes
a
you hold it.
worksheet.
Algebra 1 is the only time that I don't. I mean, algebra review is the only time I don't, because the algebra reviews are usually too short, and then I know that no one will be paying attention if I hand it out first. These are just complicated enough. What is that beeping sound?
It's
It's
a-
the construction.
I would think that it would stop by now.
Yeah, they just probably left it.
This is one of those things where as soon as you hear it once, you can't stop hearing it. Right?
Yeah, like your heartbeat and the screaming of it.
Oh, don't you hate that when you're trying to fall asleep and all of a sudden you hear your heart?
Yeah.
And I'm like, oh, just stop. I
Because I
can't.
stay up to the point where I just pass out right away.
All right, here we go. I'm going to warn you, today is absolutely a medium day. Big picture, the so what about all this is pretty simple. But it's to getting there and being able to write it all down, it's a little complicated. All right, here we go. Ratios. Ratio is a big fancy word for?
Number.
Ratio is a big fancy word for?
Fraction.
Fraction. Right, we're going to be making a fraction. Okay. This is about areas and ratio. The easiest way to do this is to just simply do it together. So usually I'll have like a couple examples and then we'll do one together. We're going to do these all together. So everybody look at your paper, box 1. We have technically 3 triangles there, a big one, and then 2 medium ones, or maybe you might say a medium and a small one, but we have 3 total triangles there. We will only be talking about 2 of the triangles. So take the big one, it's cut, not necessarily in half, but it's cut. You can see BD cuts the triangle into a, is that green and orange, I think? Green and orange or brown, something like that. What? Okay, green and red. So it's broken up. Those are the 2 triangles I'm going to talk about. So I'm talking about ABD and CBD. Okay, those two triangles. So it says, what is the ratio? Ratio is a big fancy word for fraction. Okay, what is the ratio of the areas? That's the key there of the two triangles. So you got to pick what you want. You can put anything on the top of the fraction, anything on the bottom. You got to pick. You can either go green to red or red to green. I'm going to go green to red, right? I called it orange. We ready? Okay, I need to make a fraction that talks about their areas of green over orange. So what's the area of the green triangle? Well, what's the formula for area of a triangle? You said it yesterday, Matt. Okay, so I know there's no numbers there, but there are variables. Use the variables. So what is the green one? Green one. You just said it's base times height divided by 2. So it would be
AD.
AD is not a height.
I'm saying the base.
Base is A, I got it. What's the height?
B.
H over
2.
Okay, so there's your first one. Okay, see that? How about the orange one? God, that's bothering me.
B times.
Is it DC? Isn't that the base? DC?
Well, use the variables they give you.
Oh, I didn't see that.
Well, now I have to
That's
draw
why
the
I'm so
triangle.
confused. Okay.
It is on your paper as well, too, Matt.
B times H.
Over. Okay, good. Now it says make a ratio, fraction of these two things. I got to make a fraction, and I said let's go green to orange. So I need a fraction. So here's your numerator. Here's your denominator. Looks really weird. You agree it would look like that? There's my ratio, yes?
Painful, yes.
And it turns out that it's not painful because guess what we can do with this? Ethan, you're the one that always gets this one. What can we do with this? We can move the things around. We can do a copy dot flip, right? So I'm going to copy the top. I'm going to flip the bottom, yes? Watch the magic that happens when I do that. We okay with that idea if I can just do a copy dot flip there? Look what happens when you do that. I copy the top. I flip the denominator. Now watch what happens, Cadence. You should get A over B. Do you see that? The 2's would cancel, the H's would cancel, and you'd be left with A over B. Now, you won't know why I'm pointing this out, but A and B are the bases of the two triangles. You're not going to know why I'm doing this, but you will in a couple slides. So it turned out that we did the ratio of the areas of two triangles that had the same height. We get base 1 over base 2. Okay. Yes? Okay. Let's do it again. Here are two triangles, a light one and a dark one. We're going to ignore the big one. Light one and a dark one, and they both have the same what this time? They have the same base. The previous one, they had the same heights. Now we're going to talk about what happens if they have the same bases. Okay? I'm going to do the same thing. We're going to make a ratio of their areas, but this time the two triangles have the same base. Tell me any word that I said in that last sentence there, Danny. No, but good shot. I guess my point there is, come on, pay attention. Let's go. Okay, so I'm going to make a ratio of the two areas of two triangles that have the same basis. So I'm going to go light to dark. And I could go dark to light as well. It doesn't matter. You get to make your choice. Okay, Wes, give me the light one. Give me the area of the light one.
Would you, so you kind of ignore the dark one, right?
Yes. Well, I don't know what else to call them.
White and blue. So base times height. B A divided by 2.
Yeah, there's the area of the first one. All right, Connor, give me the darker one right here. What's the formula for area of a triangle? Okay, base times height divided by 2. So look at the dark triangle. Tell me, where's the base? Where's the height? Don't overthink it. Just look at the height. divided by. Yes? All right, Matt, set me up. Light blue to dark blue. And we're considering this the bigger one, the light one.
It's literally gonna be 0.
No, you gotta see first. Give me the big honking fraction now.
VH over 2 over BK over 2.
Okay. We good? Now we're gonna do a copy dot flip. What happens?
2's cancel. Sorry, it's gonna be H over K.
It's gonna be H over K. Now you don't know why I'm doing this, but suspiciously, why did I
Why did you
cancel?
cross out the H and
It's a
K?
mistake. Ignore these are not the droids you're looking for. I'm trying to cancel the B's, not the H and the K. So we got H over K.
H to the K then.
It's just a mistake.
It's just a mistake, right? You don't know why, but suspiciously, I'm going to write that as height 1 over height 2. I'm going to bring this all together at the end. Don't worry.
So if they're the same height, it's just the two bases.
If they're the same height, it's the two bases. If they're the same bases, they're the same heights. Good observation. Okay. Last one. And then we'll put it together. We get 2 theorems out of this. And just so you know, I'll fix it right now.
Get another one.
There we go. Much better. Good day? Okay. Last one. Look at the board. Hey, you two knuckleheads, stop. This time, I have 2 similar triangles. So when you have 2 similar triangles, I'm going to compare the areas of the 2 triangles. Okay? And I'm going to go, let's go from small to big. Small triangle to big triangle. Okay. Wes? Area of the first triangle?
VH over 2.
Okay. Area of the second one?
K over 2.
Okay. Big honking fraction would therefore be?
VH 2 over E.
Okay. Copy dot flip, and what happens? Let's see if I messed this one up.
2's cancel.
Anything else cancel? No. Now I'm gonna need another.
You messed it up.
I did mess it again. This is not a good day. But that's right. BH over EK. Now, ordinarily I would say that's something I'm gonna hold off for a second. I'm going to another slide. So we just found out if you have 2 similar triangles, that you eventually get to that ratio right there, BH over EK. On your new slide. Continue. Okay. So that we got that. Yes? Okay. Well, let's think this through. There is a way to reduce this to make something a bit more nicer, and that's what I'm about to do. Okay. So if I take this fraction right here and split it up, that would be B over E times, okay, that's all I did was just split it up. Okay. Now here's the reducing that I actually can do. Well, B over E, let's just leave as B over E. But H over K, if 2 triangles are similar from chapter 6 or 7, I forget which one it is, said that when 2 triangles are similar, we can write their sides in a proportion. Remember the thing where I said, hey, just choose a pattern. Any pattern works. So if I say H over K, if the 2 triangles are similar, H over K would equal, so same pattern. H over K would equal, I can do that. And you're like, well, why would you do that? Well, watch what happens. We just said that this, which is what we were trying to reduce, can be broken up into this. Well, what's left over here is an H over K, right? What does it say that H over K is equal to?
B over E.
Ooh, so I can take that, instead of writing that, I can write
B over E.
that, which is B over E, and then what does that turn into?
B over E.
B squared over E squared. Now, what was B? What was E? When 2 triangles are similar, guess what you get as a ratio? The 2 bases squared as a ratio. So base 1 squared over base 2 squared. So we just did 3 things for those of you keeping track. We need to write them down, otherwise we're going to forget them. Okay, so let's write this down. By the way, that's actually the scale factor squared. Remember, the scale factor of 2 similar triangles are any 2 corresponding sides written as a ratio. I just did that. That's the scale factor. So there's our 3rd and final one. We need to write this down. So in your book of truth, we'll just summarize what we just did. We found out that if 2 triangles have the same height, then the ratio of their areas equals the ratio of their bases. We get that right there. This is going to be a lot of writing, by the way.
Yeah.
Now, for those of you that want to be lazy, you need to write these words. You need to write equals base 1 over base 2. You want me to continue, just throw all 3 of them up there and you just copy? Okay. The second thing we found out that if 2 triangles have the same bases, Caden said, then it's the 2 heights as a ratio. And the last one we just found out is that the 2 triangles are similar. Then we don't get a ratio, we get a scale factor squared. You absolutely positively need the words in black. And if you want to skip on something, you can skip on the yellow part and just write base 1 over base 2, height 1 over h2, or scale factor squared. Remember, scale factor is any 2 corresponding sides squared of 2 similar triangles. I said today was medium. This is the medium part of the fact that it's a lot to remember. You're not going to remember it. Mike is like puzzling over the homework. Once I show you a couple examples, a little bit easier, but it's still kind of medium. Not as easy as yesterday, though.
No, unfortunately not. I was hoping this entirely could be a
The table's really easy. I just
table is easy. You just need to figure out the right factors.
Have fractions that one.
2 of the 3 all involve fractions.
the table is making my soul bleed. So
The book loves tables.
I hate tables. Really just go back a page and look at what
Uh, So mathematicians like tables. So if you were a mathematician, anyone in, like, we're all together as teachers, right? And they ever put a math person or a science person in charge of taking notes. When you have a language arts person to take notes, guess what it looks like? Words, sentences, paragraphs. When a math person takes notes, it looks like a table. It's just the way we think. It's like, I want things nice, neat, and orderly in their little box. And
We need more math books for younger people. Or just people that don't grasp the concept of it.
well, I would firmly agree that there are math people and non-math people. There's a lot of people that argue that don't ever say that everyone can learn math. Agreed. Everyone can learn math. I think everyone is able to learn math at different velocities. Some people can get it very quickly. Some people, like, it takes a very long time. The speed of you learning it, some people can learn it very quickly. Some people, it takes a lot of time. This is also why in life kind of points you in the direction of where your talents and interests lie, and that's where you find out you probably get a job at, or area of study, pursuit of knowledge. It turns out if you understand what this says, it's not too bad. I mean, it's actually pretty easy. If you don't understand what this says, you're going to have problems with it.
So it's literally what we did way back in that chapter, right? With the
It's a little bit like that.
So it's kind of, so you just take the height, you put the, like.
Well, we're going to give you problems where the heights are the same, or we're going to give you problems where the bases are the same, or we're going to give you problems where the 2 triangles are similar.
And then you have to find out the other.
And then you're simply going to do right there, right there, right there.
So it's basically the same as what we just put.
This one is a plug and chug, absolutely 100%. All right, we ready to move on? A couple examples. All right, that is a lot. Basically, it boils down to this. You're going to be given two triangles that have the same heights. If they have the same heights, you use that formula. You're going to be given triangles that have the same bases. You're going to use that formula. You're going to be giving two similar triangles. You're going to use that formula right there. And that's kind of it right there. Okay. All right. Now let's look at some examples. They give you the worst possible example in the book where they use this one shape, it's on your paper, for three different problems. Because there's lots and lots and lots of triangles inside this trapezoid. You see them? Like there's lots of triangles. So it's going to be three problems using this one shape right here. All right. Here's the first one. It says, what is the ratio of the areas of COD to AOB? Step number one, you got to look and identify where the heck are these triangles. Okay, so let's see. COD. COD is this top triangle, the yellow one. You see it? Where's AOB? It's the bottom triangle. So it's the two colored triangles that we're dealing with. Okay, you ready? What do you notice about the two colored triangles as indicated by the marks? How do you know they're similar? It's a good guess, though, and it's right. Well, we're given one angle. How many angles do we need if they're similar? Two. Do you have a second angle in those?
Yeah.
Vertical, right? Very good. Very good. So we know that those two triangles are similar. How do I know they're similar? Because angle. Okay. So now look at your sheet you just wrote down. What formula are we going to use? Scale factor squared. So what's the scale factor? To find the scale factor, you go to those two triangles and you match up two parts that have numbers. By the way, how many numbers are up there? This one's an easy one. Now it doesn't say, oh, it does say, it says COD to AOB, so we got to go to COD. What's the only number up here? It's only a number up here. So the fraction would be 3/5, but we got to square it. Okay? And that's the answer.
Really?
Yeah.
I don't trust it. It's too easy.
Well, go back to my old saying, like so much of advanced math is seemingly hard, and then you finally understand what's going on. You're like, okay, that's easy. All right, let's do another one. Same shape, just different configuration. What is the COD to AOD? Where are those? COD to AOD, can you see them? COD is easy, it's the yellow one again, but where's AOD?
On the left.
So I made it a little bit easier for you to see. You see it? How in the world do I know that they have the same heights? Because they have their bases come from a similar line, or I can say similar line, come from the same line, AC. Okay? I don't know what their heights are, but I can put H for height, correct? So both triangles have the same height. Now they give you some values right here. Okay? I left that off of my diagram. So what formula are we going to use? If they have the same height,
Is it base over base?
it's going to be base 1 over base 2. So what's base 1 here? And remember, you got to make sure you pick the right triangle. COD. COD has a base of, and AOD has a base of. You got to stop me if you're lost. They have the same height, so we put base 1 over base 2. And you said that was 3x over 5x, so that turns into everybody else beside Cadence, 3 over 5. Can you see it? Yes? No? Maybe?
Yes.
Okay. The hardest thing is, well, it's not, the process wasn't hard. The hardest thing because they gave you this particular shape. Okay, last one. OAB to DAB. Where's OAB? OAB, okay, the bottom one. To DAB? Ooh, that's this big one right here. So I'll draw it for you right there. Do you see it?
Do the same height, yeah.
They're not the same height.
The heights are 5 wide.
The heights are 5 wide and 3 wide. What do we know about those two triangles? Well, their heights are not the same. This is hard to see. You got to draw them separately to see this thing. The first one was AOB. So AOB is this one right here. You see it? And where's DAB? DAB goes like this, this, this. Both of these have the same. They have the same bottoms. They both share AB, AB. So they both have the same base. The heights are different, 5y, 3y. Okay? Do you see that? So when the bases are the same, what's the ratio?
The heights.
The heights. So what's the height of OAB? Now you got to be careful. What's the height of DAB? I heard 3y and 8y. Which one?
8y.
Why not 3y?
That's way too short.
Well, it says 3y right there.
That's not DAB.
That's not DAB. That's this dotted triangle right here. DAB would be from here to the top. That's 3y plus 5y. That's 8y. Okay? So that would be 5y over 3y. Therefore, it would be 5 over 8. Okay? Cool. You just did one example of each one. None of them are that hard, but it does take a little bit of, I don't know, looking around to figure things out. All right, so where do we stand? Same heights. The formula is? No, you really want to say that, but no. It's the bases. If the bases are the same, it's the heights. And if they're similar triangles, it's scale factor squared. All right, that's not bad. Turns out we get one more thing. I said the 2 theorems. Here's your next one. So it turns out more broadly, write this one down. If you're given the scale factor of 2 similar triangles, if you're given the scale factor of 2 triangles, for instance, A to B, then this is what we get. We get 2 things out of it. If the scale factor is A to B, well, then the ratio of the perimeters is also A to B. So there's your first thing. You got 2 similar triangles and you're given the scale factor. Well, then the perimeters are the same scale factor. And this was that second part, the scale factor squared part. Then their areas will be A squared to B squared. So we're not going to have a total 5 things that we can say about triangles. Heights are the same, base 1 over base 2. Base is the same, height 1 over height 2. Triangles are similar, scale factor squared, and these 2 things. If you know the scale factor, the perimeters are A to B. If you know the scale factors, their areas are A squared, B squared. And those are all written as ratios. So 5 total, that's why this one I think is definitely a medium one. It's a lot to remember. Done or not done?
Done.
Okay.
It's definitely medium.
Definitely medium. And then I only have one example, and it's a somewhat simple one. We good? We have it written down? Connor? Chandler, did you try the homework? I need my buttons to push the recordings. Good enough? Okay, so here's the one example. You got 2 pictures of Texas. We're going to say that small Texas is similar to big Texas. So if you have 2 similars and you're given the scale factor, look, I got the scale factor, 8 to 12. You get the idea. All right. If you're given the scale factor, then you're like, well, where does it say scale factor? Well, remember, if 2 things are similar, you take any 2 corresponding measurements. Basically, they're giving you a measurement of left to right, a width measurement here. Then the scale factor is measurement 1 over measurement 2, 8 to 12. Okay. So find the ratio of their perimeters. So if the scale factor is at 8 to 12, guess what their perimeters are as a ratio? They're not squared. That's the areas. Their perimeters are exactly the same. Their perimeters are also going to be 8 to 12. Now you can reduce that. Okay. What's the second thing it says? It says that if you have 2 similar figures and you are given a scale factor, then what's the ratio of their areas? So what's going to be in this case? 4/9. That's, that's how it's done. So 4/9. Now, if you really wanted to make it complicated, right, you'd square the 8, the square of the 12, but sometimes it's work smarter, not harder, to go from 2/3 to 4/9. It would be easier to square the 2/3 than it would be the 8 squared, 12 squared. But if you forget, it still reduces to the same answer. And that's it. That's the whole thing. 5 things. 5 things. All right. You want to call one out? How much time we got left? How much? A couple minutes. You want to open up your homework? Call one out. We'll do it.
Recommendation.
Yes? No? Maybe? No? Yes? What? You guys are like bumps on a log.
I'm really tired.
Oh, it is Friday. We haven't had a 5-day week in what, 4 weeks? Remember, we had 2 snow days for 2 weeks in a row before spring break.
Schools for 1 day.
And then quarantine.
And then quarantine for 2 weeks.
And then spring break.
And then spring break. And then we're back for 5 days.
Thing with the compass and opening the
Well,
compass.
this has been our first full week.
Yeah, I'm saying it has in over a month.
Miserable day.
All right, well, I offered
Not for you.
3 answers.
For the rest of us.
You know, Shannon, you can be quiet. You went through your silly goose.
All right, e-learners, if you have any questions, send me a chat or email. If not, have a great weekend, and I'll see you on Monday.